Good morning, students. You all remember that our chapter on gravitation is complete, and now we are moving to the last chapter of the first book. Okay, that is System of Particles and Rotational Motion. This is the last chapter of the first book, System of Particles and Rotational Motion. Okay. Before I start this chapter in a full-fledged way, I want to discuss some important points. I will suggest you to write these definitions also. So, we are starting with very fundamental points like particles. What is the meaning of a particle? There is a system, internal forces, external forces. Let us discuss regarding these points first. So first of all, what is a particle? You can write a particle is defined as an object. A particle is defined as an object whose mass is finite. So a particle is defined as an object whose mass is finite and whose size and internal structure can be neglected. Okay, that means a particle is that's a very small object. It has a finite mass, but its size and internal structure is neglected. That is called a particle. Then next point is the system. What is a system? A system is a collection of very large number of particles. Okay. So what is this? It is a collection of very large number of particles. It's a collection of very large number of particles which mutually interact with each other. After that, there is a point called internal forces. Actually, these are the mutual forces. Internal forces are what? These are the mutual forces exerted by the particles of the system on one another. So, mutual forces exerted by the particles of the system on one another. And external forces. Then the external forces, these are the outside forces which are acting on the particles. These are the outside forces which are acting on the particles. These are the four terms. But now what I want to discuss, that is a very important point, that is the center of mass. Actually, initially we are starting this chapter with the center of mass. We shall discuss what is center of mass. Very important point, and I think very interesting to discuss also. What is the center of mass? Center of mass, you can say, center of mass of a body or a system. Center of mass of a body or a system is a point where whole mass of the body is supposed to be concentrated. Where whole mass of the body is supposed to be concentrated. Where the whole mass of the body is supposed to be concentrated. I hope you got what is the center of mass. The center of mass is the point in a body or in a system where the whole mass of the body or the system is supposed to be concentrated. We consider that it is concentrated at that point. The whole mass of the system or the body is supposed to be concentrated. We are considering that it is concentrated there. And obviously, one more point may come into existence, that is, you can ask also, what is then the center of gravity? Obviously, you can ask, then what is center of gravity? Then I will say, center of gravity is the point in a body or in a system where the whole weight of the body or the system is supposed to be concentrated. यानी दोनों में एक छोटा सा अंतर है. सेंटर ऑफ मास एंड सेंटर ऑफ ग्रेविटी में एक छोटा सा अंतर है. A small difference, very small difference. What is that difference? The difference is this, that in case of the center of mass, we have said the whole mass of the system is supposed to be concentrated at a point in a system or in a body. And in case of the center of gravity, what we have said, it is a point where the whole weight of the body or the system is supposed to be concentrated. यही दोनों में आता है. Right. Then what is the basic difference between the two? As such, if I take it on the surface of the earth, in our case, there is no as such any difference. The difference is there where gravitational field is not uniform. We have done gravitation. Mind this. We have discussed gravitation. So gravitation में हम लोगों ने क्या देखा? ग्रेविटेशनल फील्ड, जहां पे ग्रेविटेशनल फील्ड यूनिफॉर्म है, वहां पर जो सेंटर ऑफ ग्रेविटी जो होगा और सेंटर ऑफ मास जो होगा, बोथ विल बी द सेम. बट इफ द ग्रेविटेशनल फील्ड वेरीज, देन द सेंटर ऑफ मास विल बी सम एट वन प्लेस at one point and center of gravity will be some at another point. Like in case of a Mount Everest, it's a very high hilltop. In that case, since the gravitation changes, because you know, weight जब भी हम लेंगे, the effect of the gravity has to be taken. Whenever we are taking the weight of the body, the effect of the gravity has to be taken. You are taking center of gravity में weight consider हो रहा है, तो याद रहे सेंटर ऑफ ग्रेविटी एंड सेंटर ऑफ मास अगर पूछा जाए कि डू दे कोइंसाइड ऑलवेज, यस, अंडर द नॉर्मल कंडीशन सेंटर ऑफ ग्रेविटी एंड सेंटर ऑफ मास कोइंसाइड. ओनली दे डिफर देयर पॉइंट्स, दैट मीन्स द सेंटर ऑफ ग्रेविटी एंड सेंटर ऑफ मास, दीज पॉइंट्स डिफर ओनली इफ देयर इज द चेंज इन द ग्रेविटेशनल फील्ड. कभी अगर ग्रेविटेशनल फील्ड में चेंज होता है तभी इन दोनों में चेंज होगा. दोनों का पोजीशंस वैरी करेगा. एक ही बॉडी के लिए दोनों का पोजीशंस वैरी करेगा. फॉर एग्जांपल, इन केस ऑफ द माउंट एवरेस्ट, आई हैव गिवन एन एग्जांपल फॉर यू. आई होप डियर स्टूडेंट्स, ऑल दीज फंडामेंटल पॉइंट्स आर वेरी क्लियर टू यू. नाउ आई एम स्टार्टिंग इट विथ सेंटर ऑफ मास ऑफ ए टू पार्टिकल system. This is our first discussion. Center of mass of a two-particle system. Let us consider the center of mass of a two-particle system. What is this two-particle system I want to discuss? So, center of mass of a two-particle system I want to discuss. Look, I draw a figure here. Y-axis, X-axis. Okay, dear students, let us see this figure. We are discussing the center of mass of a two-particle system. The upper line may not be visible for you, but just I am telling you, it is the center of mass of a two-particle system. What is there? This is XY plane. In this plane, there are two particles, M1 and M2. Two-particle system. M1 and M2 are the two particles whose position vectors are R1 vector and R2 vector respectively. Okay, this is a joining line, the line which is joining the two. And what happens here? In this we can say a force F1 vector external force, F2 vector is the external force. Sorry, F1 vector and F2 vector are the two external forces are acting on the particles M1 and M2 respectively. Then what we can say here? We can say here F1 vector and F2 vector are the external forces acting on M1 and M2 respectively. Moreover, F12 vector is the force, I write here, internal force on M1 due to M2, and F21 vector will be definitely internal force on M2 due to M1. Look, I hope these 2 points are very much clear to you. These 2 points are very much clear to you. We have discussed it in the 4th chapter. If I say F12 means force is acting on 1 due to the 2, and F21 means force is acting on 2 due to 1. Okay, so these things are there. Now in the next lecture I am continuing this discussion.